And here we are on the bench with this corroded Addams Family Gold MPU, which I have repaired, and you can see the white dots on the two LM339s and the ULN 2803. Those are new chips, and the 12 10K pull-up resistors just above there are all new also. I've installed NVRAM on this board and installed a 4.27 volt reset voltage reset voltage watchdog. And C31 I always change. I install it like that so that you can see that there's no corrosion below that cap, as happens with some of the old Phillips caps that Williams used. And of course the power header. I've got a power driver board that I'm testing at the same time, and power headers all the way around on it, and the GI headers. And here's the 5 volt power out. Again, this radial cap I have bent over so you can see that it's not leaking. There's another one at C4, which is sometimes involved in resets. This board had somebody had fiddled with all the 15,000 microfarad caps, so I removed them all, replaced them all. I don't generally do that, but this one, it just seemed warranted to me. This one is, I don't know what, I guess that's nicotine on it. This will clean up nicely once I get it outside under some Castrol Super Clean. I fixed the, the stilted tip 102, the whole drivetrain of 5401, tip 102, tip 36 was mounted high on the board. I don't see any reason to do that, so I removed them and installed them correctly. And we should be good to go on both these boards, but let's see, this is the first run through. Never know what I'm gonna find on the first run through. I don't have a sound board attached. Let's set that date and time while we're in here. All right, good to go on that. So let's do adjustments. And one of the things I like to do is turn on the minimum volume override. And then, I don't know if this ROM implements free play automatically or not, so I'm just going to set this to free play. Alright, now we can back out of here and do some testing, and switch testing is important since there's a large amount of upheaval down here in the switch matrix section. So let's go across the diagonal of switches. Well, that's not good. Looks like switch rows 1 and 2 are connected together. Let me show you that again. Interesting. Let me go row 1. That was column 1. Duh. Here's row 1. Yeah, row 1 and row 2 are connected together. So that'll be fun. We go track down. These are the coin door switches and coin drop switches. So I got one thing to fix there with the row 1 and 2 being connected. Let's check solenoids on this driver board. And why don't I have some solenoids here? Very interesting. I guess we'll figure that out too. No solenoids are operating. Let's do, no general illumination is operating either. I must not have something connected here. And and no lamps are operating either. What could this be? Oh, I see it right there. That's not a great connection, is it? One moment. Okay, while we're rebooting here, let me talk about these two LEDs. This is LED 2 and LED 3. These are line level indication LEDs that Williams designed into the board. In practical use, they don't tell you a darn thing, whether they're lit or unlit. It was supposed to mean either high or low line level, but in reality, they're not very useful. The 5 that are useful, I call the bow tie of LEDs, and I've got to get all the way over here to see these two. There's 2 here, 1 in the center, and 2 over there, so they kind of make a bow tie. So I will ask people, is the bow tie of LEDs lit? And hopefully that gets me further down the diagnostic path. So the second boot, it's going to think that none of these optos are working, and they're not, of course, because we're not in a game. So let's go back to tests. Let's see if these... Aha! Once I connected those up, they're no longer connected together, row 1 and 2. I don't know exactly why that is, except that Addams family uses a -1 power driver board. And the -1 has all this populated, and in particular this U7 and U8 are 4N25 optocouplers, and Addams family uses that. Does Addams use that? Well, previous non-Fliptronics games use those 2 optocouplers to tell when the flippers have been actuated. I'm not sure if that's really the cause of what I was observing or not, but the fact remains that is working correctly now. So let's get out of this, and now let's try a solenoid test. And I'll make it run. This one, solenoid 8, did not fire, and that is the lockup kickout. So I'll have to look into that on this driver board. And I want to see what this 28 was. Swamp release. All right, so that's okay. We'll do the GI test now. I already rang the traces for GI dimming on the PCB itself. It's just more efficient to do it like that. That's working correctly. Let's do lamps and flashers at the same time. So we have all the lamps and all the flashers working. Let's go back to solenoid test and check solenoid 8. Yeah, and it's inoperative. I can show you what there's a method of getting some help. I'll press the start button, and that lock-up kick-out hole should have those color wires. Power source at J107, and the drive is at J130, that was, and there's the fuse. So the first thing to do is to check the fuse. Let's see, Q70 was in that train. That may be the transistor that I was working on earlier. No, it is not. I was working on this one. I can't see what that is right now. I'll check that out. No, what was that other one? I'm moving a little slow this morning. Swamp release working just fine. So we got to go find out what the problem is with the lock up kick out, and that is J130-9 F105 and 70, 69, 59. One moment. Well, here's the reason that the swamp kickout wasn't working. You can't see it very well, but this trace between the drive leg of the tip 36 and the drive pin of the header, this trace is missing here. It had blown off, and I remembered that when I was reworking this board last night. There was a janky looking wire connection there, and I removed it with the intent of adding a better jumper, and I forgot to add the better jumper, so let me add that one back in. Jumper in place now. I used 0 ohm resistor. I wanted to rule out the possibility of a wire like I usually use touching either of these legs, so that clitellum that they put on these 0 ohm resistors so that they can use them in pick and place machines will isolate this jumper from these other connections. All right, back in operation, and we have booted. Let's ignore all these test reports. Get into tests one more time. Solenoid test. Advancing to the solenoid, which was problematic before. No longer with the jumper though. So she is good to go. Both of these boards are good to go right now. Here's everything I did to the driver board. I didn't note something small like re-adding that jumper in there. Got the 100% Chris on there. I don't put the 100% on there until I have actually tested the board out 100%, obviously. And over here on this CPU board, that's what it took to get that baby running again. So the last thing to do is to get back to bookkeeping. And then I remove the diagnostic button connector, install my own custom connector, and then from bookkeeping I'll get my Arduino driven device going by pressing the button down here, and the green LED indicates that the software is executing, and this is going to automatically enter my message as a custom message on this MPU board. And it's funny, I got a call from somebody in California, I believe, and they said, "Who is this?" And I said, "Well, this is Chris's Pinball Repair." And I said, "Hey, did you know that your name is on our pinball machine?" It's gonna type out that message. So both clients, thanks for sending the driver board, and thanks for sending the MPU.